I'm going to walk you through one of the problems where we use on the balancing the chemical equation where we needed to use the algebraic technique. And again, a great example of something that could show up on the test. So we have this equation. Remember, first thing we do is we apply the alphabet. Every part of the equation gets a letter of the alphabet. We look at this, and this point is very, very important. You see that there is a nitrate on both sides. However, you see there's a also underneath letter D there's another nitrogen. The problem is on the other side there's no other nitrogen except the nitrogen and nitrate. Therefore, we cannot isolate the polyatomic ion nitrate. So we must look at the nitrogens and oxygens as individuals here. So my silver gives me my equation. I have two silvers and A equals C. My sulfur, I have 1 in A and I have 1 in E, so A equals E. For my hydrogen, I have 1 in B and I have 2 in F, so B equals 2F. For my nitrogen, I have 1 in B, I have 1 in C, and I have 1 in D, so B equals C plus D. My oxygen, I have 3 in B, I have 3 in C, 1 in D, and 1 in F. So I have 3B equals 3C plus D equals F. Remember, the equals is when you're moving across the yield sign. And a lot of you have gotten this far with no issue, but let's go ahead now. The problem is we have to apply a value for each of these numbers. And so we're going to say, first of all, A equals 1. So when A equals 1, then that means, well, then A equals 1, then C equals 2. If A equals 1, then E equals 1. So far it's been pretty easy, but now we run into issues. And we have to actually try to isolate a variable. So in this situation, what we're going to do here, we're going to start with our equation B equals 2F. So I know the B is the same as 2F. So when I go down to my next equation, I know B equals C plus D. Now I already know C, so I inserted my 2 into that C. Now I'm going to replace B with 2F because I know B is the same as 2F. So now I create this 2F equals 2 plus D. Now I have to find a value for D as well. So if I isolate D, subtract 2 from both sides, I know that D is the same as 2F minus 2. So now as I go back and bring in my third equation for oxygen, I have 3B equals 3C, C equals 2, so it's 6, plus D plus F. Well, I know that my B is replaced by 2F, so I have 3 times 2F equals 6 plus D. Now what's D? D was the same as 2F minus 2. So I end up having 6F equals 6 plus 2F minus 2 plus F. So I've isolated now my only variable present in this actual equation by way of substitution is the letter F. And so I can actually solve for F, and F equals 4/3. So as F equals 4/3, now that allows me to go back and actually solve for B. And B, how I do that, I would then take B is, I'm sorry, now it's going to allow me to solve for D. If I know F is 4/3, then 2F equals B is 8/3. Going after D, I know D is equal to B minus C. And so I take my 8/3 minus 2 and I end up with 2/3. So D equals 2/3. Now my common denominator here is 3, so I multiply everyone through by 3 and I get my coefficients for the balanced chemical equation, and I just plug them in appropriately. So it is a 3 to 8 to 6 to 2 to 3 to 4 mole ratio. Remember, these coefficients in the balanced chemical equation are a mole to mole ratio.